Welcome to my channel. In this video, I will be explaining about comparison of hot working and cold working. So I have already made videos on what is hot working and what is cold working. Check these videos so you will be better able to understand this comparison. So let's start. The first comparison component is temperature. So what is hot working and what is cold working? This is the first comparison. So hot working is done at an elevated temperature. The temperature is above recrystallization temperature and below melting point of that metal, and cold working done is at room temperature or at elevated temperature, which may be the below melting point of that material. This is the big difference. So hot working is done at elevated temperatures, typically above the material's recrystallization point. The metal is in a pliable or malleable state. So in hot working, the metal is at semi-solid state, which helps us to deform the metal very easily. But in cold working, the performed at or near room temperature below the material's recrystallization point, the metal is in hardened state. So we have to face difficulty to deform metal in cold working. The examples of hot working are hot rolling, hot forging, hot extrusion, etc. And the example of cold working are cold rolling, cold drawing and cold forging, etc. So these are the differences depends on temperature. Next point is material hardness. In hot working, the hardness of the material reduces, but in cold working, the hardness of the material increases. So if we doing hot working, we don't face any problem to deform the material because the material is in semi-solid state and the hardness of the material decreases. So we can easily shape the material in hot working. But in cold working, the material is in its original state or solid state. So the material is in hardened state. So we face difficulty or we have to apply more force than hot working. So we can't easily shape the material in any shape. But if we apply more force, then the material may be brittle in cold working. The next point is mechanical properties. In hot working, the grain structure of the material generally is coarser. But in cold working, we can get fine grain structure. So in hot working, for coarser grain structure, we get better ductility and reduced strength. But in cold working, the increases strength and hardness but reduce ductility, and also we get finer grain structure of the material. Next is precision and tolerance. In hot working, we are handling the material at an elevated temperature, so the dimensional stability is not accurate or the close tolerance we don't get here. But in cold working, we are handling the material at room temperature, so we can get a close dimensional tolerance. In hot working, the dimensional stability is not proper, but in cold working, we get a proper dimensional stability of that product. This is the difference or comparison. Next point is energy consumption. So in hot working, we have to heat the material at an elevated temperature. The temperature is above recrystallization temperature and below melting point of that material. So the temperature is very high or likely high, greater than cold working. So the energy consumption in hot working is more, but in cold working, we can do the cold work at room temperature, or we have to heat the material below the recrystallization temperature of that material. So the energy consumption in cold working is lower. Next is residual stresses. In hot working, fewer residual stresses introduces, or the residual stresses if present in the material get reduced or gets eliminated. But in cold working, the residual stresses increases or more residual stresses can find inside the material. Next is applications. So the hot working, the common processes are forging. In forging, large components can made through forging, large components can made through extrusion, can make complex shapes, and in rolling, large sheets or plates can be made. But in cold working, large reduction can be possible, so we can't make large product, or we can't make complex shapes, but we can make thin sheets, wires and components, which components have tight dimensional tolerances. So in hot working we can't make tight dimensional tolerances, but in cold working we can make tight dimensional tolerances products. Next is cost. So in hot working the cost is expensive, so the product we make is more costlier than cold working. So there is energy consumption is more and the equipments for heating are costlier, so the product made with hot working is costlier than cold working. And generally in cold working is more cost effective, especially for high precision components. We are making high precision components in cold working and the energy consumption is less, and we also get the more price for high precision components, but we have to pay less for this setup and the process, so the cost effective is more in cold working than hot working process. Next and last is the example. The examples of hot working are manufacturing large structural components for construction. So we are using manufacturing large structural components for construction using hot working. In cold working, using cold working, we are producing precision components for electronics or automotive parts. This is the huge difference in example. We are making large component in hot working, and in cold working we are making small components which have precise dimensional tolerances. So these are the comparison between hot working and cold working. Hope this video was useful for you. Thank you for watching this video. For more updates, subscribe this channel and hit the bell icon.